Hey everyone, thank you for joining for our virtual mug recap today. In this recap, our MongoDB Champion Shrey Batra and our mug leader Sumanta Mukhopadhyay will take you through the world of app-driven analytics and share how to create complex queries with the powerful MongoDB aggregation framework. They will also explore the world of visualizations with MongoDB charts. Do check out and let us know how did you find it in the chat below.
First of all, thank you so much for joining us on a Saturday morning. I know it's weekend, everybody's already geared up for the party and everything, all the weekend plans, the house chores, everything. Bear with us for a few hours and it's going to be fun. I promise it's going to be fun and very engaging. So with that, I will kick off. I am Sandhya. I'm part of the solutions architect team here in MongoDB. I'm based out of Udaipur for now, but I've been in Bangalore for, I guess, 10 years. And then native being Jaipur and all that. So it's a mix of places I've been to. So I've been with MongoDB for, I guess, about 1.5 years. So it's a pretty good and a pretty fast-paced life here. So what I would be doing is I would be talking to you about the MongoDB overview. And I'll be covering the introductory slides for you. Basically, we will talk about what MongoDB is. I mean, we know it's a database, but what MongoDB is and what kind of things does it have? How is it different from relational databases? And I'll focus less on the deck and more on the demo. So, it's very good and active keeping on a Saturday morning. So with this, let's begin with the overview, right? MongoDB is a database. MongoDB is a document database. It's a document NoSQL database. And in your whole database paradigm of consistency, availability, and a partitioning, where basically it is a CAP theorem or a Brewer's theorem that says no database can lie in all three spectrums. It can at most be in two. So consistency being no matter what you do, the data must be consistent across multiple nodes. Availability, as the name says, the database has to be available despite any, kind of interruption, despite any presence of failures, whatever hindrance may happen, the database must still be available. The partitioning property says that even if the communication is disrupted, or if there's any kind of partitions to occur, if there's any kind of network partition, your database must still be running. So at any given time, a database must fall 2 out of these 3 paradigms, and MongoDB is the C and the P of the whole, the triangular piece, I'd say, where C is the consistency and P is the partition tolerance. And this is just when I told you I'm not going to be covering a lot of theory, right? So with this, we'll talk about the technical overview as to how MongoDB has evolved. So when you talk about a relational database, and when you talk particularly about a production sort of a setup, there could be hundreds and thousands of tables. And any relational model could look like this, right? So basically, you would have a lot of entities. If I'm talking about an e-commerce application, there would be a lot of entities. There could be inventory, there could be cart, there could be order, customer, product, shipping, logistics, so on and so forth. There's a lot more. And eventually, when these models increase, there would be a natural need for normalization, post which the tables will further split more. With that splitting, you'll have more and more joins associated to the tables because you have to join these tables to interact and get the whole full picture of the data. So with MongoDB, you can go from this model, which is basically an object, and then you have an ORM layer in between, which is your middleware that understands your objects in code and then transforms that into your table-friendly format. And then finally, below the ORM layer, the boxes in pink are your persistence layer, which is your tables. So basically, with Mongo, you take out that ORM layer piece from the center, and what you come to is something like this, where the objects in the code directly talk to the objects into your persistent storage. So we've taken out the ORM in place, which means your queries would be faster. It's easier for the developers because it is these geniuses who really work day in and day out on building an app into reality, right? And the more time you spend on development, the lesser time you spend on thinking and on innovating. So we take out that whole piece. So it's easy for you, it's comfortable for you to talk and understand objects and then to be able to store the same data in object notation. To draw a quick contrast, this is what a data set between table, rather a relational or MongoDB data set look like. So on the left, you see a tabular model for a customer, which in its normalized form has about 7 tables. So I could have basic details, my name, my last name, my SSN number or Aadhaar card number. I could have the addresses I'm living in, and those could be multi-valued fields, right? So I could have one permanent address for correspondence. I could have a temporary address, probably for a job I'm at, and then I could have a work address. So ideally, all of this data set, you would be splitting into a different table and then join them. So with this is what the contrasting model looks like on the right with MongoDB. So with MongoDB, the data that you access together gets stored together. That's your thumb rule, right? From this session, the starting session, this is your takeaway, if nothing else, that the data that you'll access together gets stored together. So I could have a very amazing sort of a polymorphic document where there could be data types like string, there could be number, there could be objects, there could be nested objects, there could be arrays of objects, arrays of nested objects, booleans, dates, number decimals, so on and so forth. So this really helps me achieve that sort of polymorphism in your individual document and records as well. Now, it's easy to work with because it's intuitive. That is how your developers understand code. They work in terms of objects and codes, and it becomes very easy to handle, very easy to map to your data models. And then again, as I said, you could represent data of any structure, and you can modify that schema at any point in time. So basically, with this, you have your programmatic language access as well, for which there are a lot of MongoDB drivers given out. And towards the end, I'll also cover something around the new release of Mongo, which we announced last month, and what all is new. So we've also announced a couple of programming language drivers there, support for some libraries, and I'm going to be announcing that as well. So again, this is intuitive and fast. And I say the documents are intuitive and fast because they're stored in lesser amount of tables. So there's lesser place for you to work with for more data sets. And when you do that, you inherently are bringing everything into one table, into one collection rather. And when that happens, when you fire a query, it's going to come from the same collection and not from 10 different tables. The reason why it gives you better or fast performance is because since everything is in one place, you're not joining things and bringing them into memory again. So typically, when you fire a query to a relational database, you're trying to hit that query from the UI. It'll go to your backend, and from backend, the query is going to go to your database. From the database, it's going to pull in data from one table, then from another table, and then from the third table, and bring all that data into your memory, which becomes expensive. Because it is today that your memory and your compute is expensive and the storage takes a backseat. So with Mongo, that naturally becomes easier. There's lesser sort of that, piggybacking on the memory, on the compute, since there's easier storage and faster query execution. Also, MongoDB is flexible to adapt. So I'm basically doing a quick round of intro for folks that are new to MongoDB. So I promise I'm going to be quick with it. Okay, in terms of flexibility, your MongoDB documents are super flexible. It is as simple as an update statement. So think about an example 10 years ago where we were in an era where we had those landline phones. I'm talking easily about some 10, 15 years ago. We had landlines, we had Wi-Fi's. We would have another guy come up, connect a LAN, then build one plug to the router. There's a whole Shazam happening around it. Back then, that only way of correspondence in a verbal manner was that phone. Today, we have an office phone. There could be a desk phone. There are dual SIM cell phones. So I already have 2 numbers. I could also have a landline in case my mom's at home and she's not comfortable with the mobile. So at any given time, I'm talking about 4 phone numbers and access to 4 such numbers. Now, to be able to think about in terms of an application perspective, you don't want to make those changes from schema level, but you still want the database to accommodate all these changes. So with Mongo, if let's say today you have Hold on, I'm trying to fix the laser pen. Okay. So if today you have one individual phone number, you could store it as a string field. If tomorrow, rather 10 years fast forward, if we're talking about phone numbers, it could be a nested array or an array of objects where there could be one key of location, one key of the phone number. So it's super flexible to adapt. It's very easy to work with, and it's simple rather. Now, when I say it's flexible, the choice relies on you. Whether do you want a flexible schema or do you want strict level data governance? So with that, I say MongoDB is schema optional. It is schema flexible, it is schema optional, whichever fancy word rings in, right? And the point being, I can have 100% flexibility to my data model. I can add in any sort of data coming to me from the UI, or I could add restrictions on my data. So basically, if I'm talking about, let's hi, sorry.
I think Sandhya, we lost you for a bit. Yeah.
I'm back. Could someone let me know as to what was the last bit you heard from me, so I could, because I'd been talking, so I'm not sure as to when Zoom cut off.
You were speaking about schema last, if I remember.
Schema.
Sure.
Perfect. I will continue from there. And thank you so much for bearing with that. Okay, so I was talking about schema, and I was talking about how MongoDB is schema flexible. So I could have 100% flexibility. I could accept anything from the UI and insert anything into the database. Or I could have a strict sort of data governance rules applied to my data sets. What that means is I could do this kind of logic. I could add this sort of a validation to my data sets. And I could mention, for instance, if it's a student sort of a database for a college or university, I could mention the fields name, major, GPA, address are required fields. And the BSON type should be string. Additionally, when I talk about addresses, I want the BSON type to be object. The required field from that must be zip code, and I want both of those types to be string as well. So it is both basically. There's also another amazing thing in between where if there are any warnings, any errors in the document that somebody inserted, instead of failing on the document insertion, you could still insert it with a log level warning. So basically, you're still able to persist the data sets with a warning that, okay, something went wrong there. This person hasn't added so-and-so and so field. And then you can always reach out to this person and ask them to fill up the form again. So this way, you maintain that customer data. You also build a customer engagement and you don't lose it. You don't lose the data, basically. Again, a couple of concepts that MongoDB relies on. Some of the basic concepts are around high availability and scalability. I'm going to be super quick with this so we can then jump to the demo. With high availability, we say MongoDB clusters are highly available. Any failover, rather any kind of cutoff from one node to another could be done in under 5 seconds. And basically, this is what the MongoDB architecture looks like. There could be a primary node on top, and there could be 2 secondary nodes on standby. So those nodes on standby would be getting a replicated copy of data from the primary node. So it's a primary that accepts all your reads and writes, and then they get replicated to your secondary nodes. Great, that's all. That's replication. Nothing too complicated, nothing too fancy or complex. Very simply put, that is high availability and that is replication. That is how MongoDB handles replication. So with this, anytime a primary node fails, if something happens, if some sort of an unfortunate incident happens, any secondary would be up and running in under 5 seconds to accommodate your incoming traffic. And for those 4 seconds, you will always have the feature called retriable writes, where you could catch those temporary exceptions while your nodes were switching. Next, there's scalability, where I could have an available setup and I could have a scalable setup. So scalability ensures my horizontal scale out of my Somebody go on mute. There was abrupt noise in between. Perfect. Okay, so I was talking about the horizontal scale out, where when you have larger data sets, or if you are adhering to your sovereignty requirements, right? Let's say I want my application to be GDPR compliant and it's for the customers in the European Union. I could always set up a distributed copy of my data in the European region, and I can have a copy from India, could be AWS Mumbai, and I could have another copy put in the Americas. So this way, I also build an entire geo-distributed data set, and one part of my data could reside in one shard, and another part of my data could reside in another shard, and the third part could reside in the third shard. So that is the concept of sharding for you. There are three types of sharding. There's hash space, which is just random distribution of data. Next is, if I am to distribute my data set on a range base, for instance, give me the data set for customers for alphabetical range. I could have 3 shards for an alphabetical range defined to them. Or I could have a zone-based sharding with the same example that I mentioned, that in one geographical zone, I could add in my data, then I could add in data in another geographical zone. With this, I will be directly switching to MongoDB Atlas, which is our cloud database as a service offering. Very simply, it's just database in the cloud. And all of that, everything is the other fancy stuff that joins it. So again, all of the points here, I'm going to cover using the demo. So as I said, I'm not going to be boring you guys with a lot of theoretical content, and I'm going to switch directly to the demo where I talk about the monitoring, backup, security, the elasticity of Atlas clusters, and the cloud agnostic nature. Before I go to the demo, if I'm looking towards the side, that is my monitor for the demo. So don't think I'm getting distracted. I'm still paying attention here. Okay, I do see there are also some questions. I could take some of those live, possibly, and directly to demo, really. Then let's hope everything goes fine, right? Because it is apparently, what do you say? It's a stamp on every demo that no matter what you do, something's gonna cause a glitch. So let's see. And there are some questions. I will respond to the questions in some time, probably take them live or respond on the chat. Allow me 15 more minutes and we'll get there. Perfect. So talking about MongoDB Atlas now, when you log into the UI, this is what your landing page looks like. You would have an organization on top. There is your top level hierarchy. This could be your company or organization's name. This is a project right under the organization, and under the projects lie your multiple clusters. So this is my project, and along with my project, I have a lot of colleagues' projects created. So we have our own individual environment to play around and to work with any kind of things that we want to explore. Now, in a project, there could be multiple clusters. Some of them could be paused. Some of them, again, could be paused. So I was just testing if everybody's awake. And then some could be in the active state. Now, very simply, we will go ahead and create a cluster. And there are 3 kinds of MongoDB clusters: serverless, dedicated, and shared. I'm happy to spend a bit more time on the other 2 categories, but for now, I'm going to be focusing on the dedicated clusters. Also, if you think I'm talking too fast and the pace is too fast for you, please let me know. I would be happy, very happy to accommodate that as well. Okay, so thank you. Okay, so in terms of your dedicated clusters, there's a cloud provider in region we will begin with. So MongoDB is cloud agnostic. That was one of the features on the slide. It supports 3 major cloud providers, that is AWS, GCP, and Microsoft Azure, and it can support all 3 within a single deployment. What do I mean by that is, you can either have a vanilla setup where I could choose probably AWS Singapore only, or I could just toggle this button on that says multi-cloud, multi-region workload isolation, and I come here to play around a bit more. So just notice how these things change as and when I make a change here, right? So I can have AWS Singapore, I can have a GCP, for instance, North Virginia, and I can have Azure or someplace in Europe. Harshit is based out of Dublin, right? Ireland. So basically now I have this kind of a setup where I can scale this application. I'm deploying my application on all 3 major cloud providers. And what I've done is I've built these replica copies across the globe. That is my high availability, right? So right here is my high availability, where in case Singapore region goes boop, I would still have the North Virginia and the Ireland region to have your data up and running, which means your application will never face a downtime. The response time could be a bit slow because of the deployment regions and the deployment, the zones, but at least your application would be running and there would be no such downtime. So this is something I wanted to cover, which is your multi-cloud, multi-region workload. You can also set up a same cloud and a multi-region workload, which would be available even if there's a full region outage. Additionally, there is analytics node in MongoDB Atlas. This is where a lot of focus will be today on your analytics workload, running your aggregation pipeline. So I will take a quick minute and explain what this is. There are annotations. Perfect. So let's say I have a cluster, right? Let's name this cluster. Sample demo cluster. So what I'm going to do is now in this cluster, I will have a couple of nodes. This is my primary. This is my secondary. Let's say I have a 3-node replica set up. On this node, I can have my operational class of workloads. So the customers like me, like Harshit, like Himanshu, all of us, we can interact to your application. Additionally, what an app can do is there could be a natural nuance to run some sort of analytics on the same cluster. So let's say I also have reports, exports, I have dashboards, I have this kind of a capability. What I mean to say is you can have both these data sets within the same cluster. So this sample demo cluster can have both these nodes. They are still your individual units. Rather, they will never interfere with one another, and it'll handle your different class of workload, hence isolating your workloads. So any APIs that you write, any APIs that have to talk and build out reports can directly talk to these nodes. Any customer-friendly data, like any kind of CRUDs, any kind of read data sets, anything that the customer talks about, you can do that here. So this is your workload isolation, and this can be very well used for your complex aggregation queries for amazing class of analytics, and you'll be able to achieve that using this on the same cluster. The benefits, you don't integrate another system, so hence you don't duplicate your data, and you save your cost and your time on that additional maintenance, monitoring, infrastructure. So we cover cloud agnostic. I am gonna switch back to my vanilla deployment, which is AWS Singapore. Next comes my underlying infrastructure. What does my cluster really look like? What is it built on? So MongoDB has cluster tiers. The cluster tiers are different classes of storage, different tiers of RAM, storage, CPU. Basis your requirement, your use case or application, you can choose any class of storage. So if I am, for example, to talk about an M40, this has 16 gigs of RAM, 80 gigs of storage included in the base price, and 4 CPU cores. So I can always increase the storage to as high as 1 TB. Kind of cool. I can also enable things like auto scaling. What does auto scaling mean? In the event when there's added traffic, scale my database automatically to meet the incoming customer demand. So let me give you an example of the Prime sale. By the way, Prime sale is on Amazon for today and tomorrow. So imagine when you have this sort of a discount, this sort of a sale going on, there's very big, larger data set of users coming in, right? There's more heavy user base talking to your app. To be able to accommodate that workload and not really choke and clog, you can toggle this button on that says, if I reach 75% threshold on the compute and memory, I'm gonna automatically scale up to the next available tier. I can continue scaling up until you choose maximum cluster size. So basically, it can scale up to M50. If that doesn't suffice, it can scale up to M60, M80, and it'll stop at 140 because that's the max limit I've given. You can also allow your cluster to be scaled down. And you also have storage scaling. That says, in terms of storage, if the thresholds reach about 90%, I would first automatically expand the storage on the same cluster. And if that reaches 90%, I'm going to scale up to the next class of the cluster. I hope it was simple. I hope it was resonating with you guys. So, and I see a lot of messages. I'll respond to those. So then in the additional settings, you have MongoDB version. There's 6, which is the stable version, and then MongoDB 7.0, which is release candidate. There's backups. So these backups basically help you meet your uptimes, SLAs, and RPO, RTOs of 6 hours by default, and you can configure that down to 1 hour. MongoDB helps you achieve your uptime SLAs for 99.995%, and your RPO, RTO requirements could be met from your backups. If you have mission critical workloads, you can also reduce that frequency to 1 minute, which means if I lose my data now, which is 11:11 in the morning, I could retrieve the data for as soon as 11:10 in the morning, which is just a minute before. So this is done by replicating all of the operations under the hood from MongoDB. So anything you do to the database, anything you read, anything you write, anything you update, anything that makes change to the database, all of that will be written to the oplog, and your data would be replicated and restored from the oplog entry. Then that's it. I'm just going to go ahead and create the cluster. You could click on create cluster, and I could go to the home page. So I already have this created. This gives you a bird's eye view. This is built on version 6.0.6 in AWS Singapore. It's an M33 node replica set. The backups are active, and I have built about 9 Atlas search indexes on this. Again, this will be covered later in much detail, and there's an amazing session plan for you guys on that. So I'm naturally not going to cover it. So in terms of the clusters, this is what your cluster topology looks like. It's a 3-node replica set. This is my primary node, and these 2 are my secondary nodes. Talking about metrics and monitoring, the slide for Atlas also had comprehensive monitoring, right? So Atlas has about 100 plus KPIs for you to monitor the health of your cluster. So I don't have to worry about integrating another monitoring tool. I could use the same inbuilt out-of-the-box in-house from Mongo. So I could change the granularity. I could change the zoom period. I want this data only for 1 week. So probably not a lot of spikes here because it was paused. Then I could only see the charts for, let's say, only the primary node, or I could see the data for all the nodes. And these are what my charts look like. So if I talk about a few, you could look at your document metrics. So sometime on 12th of July, I had about 0.06 updates per second, 0.4 reads per second, so on and so forth. So this is the kind of data you can see. And if I go to primary, this is what my data really looks like, right? So I did 2 reads per second. Then there's oplog GB per hour, which is your replication room as to how much data are you replicating from the operations log. Again, a lot more metrics. I can continue scrolling down, and then I can add a few more. From the metrics, you could see that there could be a few irregular patterns forming here. I could then go to my profiler and see my slow running queries onto the database cluster. So my slow running queries could look like this, where this is a command. It took about 44 seconds, which is not good. So I can see it didn't return any documents, none of the keys examined. So it was probably an internal command that happened. And this was just an internal pipeline that occurred. So this is my Mongo T steady state, a component of Atlas search. So probably I restarted my cluster and this sort of a sync began. Again, more of this to be covered in the detail, but any point of time you have any kind of slow running queries, it will show you in a scatter gather chart, and you will be able to see the database. This happened on sample_Airbnb. The plan summary was a collection scan. If I used indexes, it would be an index scan. Number of index keys examined, number of documents examined, and number of documents returned. So some of these fields could prove super helpful when you talk about your slow running queries. Then you can have advices from your performance advisor, which will give you recommendations based on your querying patterns. It could give you recommendations to create new indexes if you're running queries on some particular fields a lot and if they're slowing down. If you have redundant indexes, it will also give you recommendations to drop those indexes or the recommendations to even improve your schema. Next, we come to the backup. In terms of your backup, this is my active set of backups as of now. And I could always take a snapshot on demand and retain it for 3 days. And I can say take snapshot. I'll receive an email as to when that is done. And I can always come back and take a look. In my backup policy, I can define and set the restrictions of when I want this backup to happen. So let's say every day I want this backup to happen at 4 a.m. And rather, I want this to be done at 4:30 every day. So my hourly backups could be taken 1 hour apart. I could retain them for 2 days. I could take a daily snapshot, stats every Saturday or every last day of the month. So these are my backup frequencies. And I can also have additional backup copies. So that was a backup policy. That is your basics onto your Atlas clusters as to what all does it have. I haven't covered the pane on the left, which is super, super important in terms of security. Harshit, do I have 5 more minutes to extend, or I can give the floor back to you guys?
No, please keep going. That should be okay.
Perfect. Perfect. Okay. So I will be able to tie this whole thread together in terms of security. And honestly, security is probably one of my favorite things to talk about at all times, right? And with Atlas, your Atlas clusters are end-to-end encrypted. What is encryption? Was there a question? I heard somebody.
I think there's some background noise.
Okay. Okay. So Atlas is end-to-end encrypted. You can have encryption at rest for your data and disk using your AES protocols. You could have encryption in flight using your TLS protocols, which is a transport layer security protocols. And then when your data is in use, what do you mean by data in use? So when the data is being fetched from the disk and brought into the memory, according to the indexes, that data is in use, that whole passage from the disk to the memory. When that sort of data is in use, it is vulnerable to memory leaks. It is vulnerable to any sort of outsider attacks because essentially your AES protects data at disk, the static data. TLS protects the data that is moving across networks. But what happens to the data that you're already fetching from the disk to the memory? For that, MongoDB has client-side field level encryption and queryable encryption. So this basically, they follow different encryption technique. I'm not going to go too much in depth. I'm aware that it is an analytics geared session, but I'm going to leave you with 2 keywords, which is a randomized encryption and your deterministic encryption. For the security enthusiast, privacy enthusiast, feel free to Google that up and it'll give you very good insights as to how these algorithms and security are implemented. With Mongo, they're both covered. So basically, I wanted to come to that point. With Mongo, they're both covered. Additionally, you have database access where you could create a new database user. So let's say I have a vMUG user Saturday, because why not? And then I could add a random string of password. So I went extra random there. Okay, so I did an extra random string and I could add a built-in role to this user. This person can only have the read access. If that doesn't suffice, this person can have a custom role. This is where your RBAC comes into the picture, which is your role-based access controls. So basically, I could have a new sample RBAC role where I've probably given read permission to 1 collection out of 10 collections in a database. So your access could be as atomic as that. And then you could also have a temporary user and you can restrict this access on specific clusters. So I want this user to only have access on Atlas 101 and only on the S3 federated instance where I have my data lake and federated queries running from S3 and from Atlas. I will go and create this user and that's it. You will see a timer right here for 6 hours, post which this entry will automatically get deleted. So that's kind of cool. In terms of your network security, MongoDB has IP whitelisting, rather MongoDB Atlas has IP whitelisting. It has your VPC peering and your private endpoint to connect to any of your cloud providers. In terms of advanced security, you have something called as database auditing, where if I enable this, you can choose which operations to audit for which users. So let's say I want to audit the data and operations for all these Scrum users. Scrum is your salted challenge response. Let me, hold on. So I have sent this, which is very simply your username and password method. So basically you can select all the Scrum users or selected Scrum users, and you can define the options to audit. So anything that you need to be audited in the log, things like a drop index, create user, drop user. I also want to audit when somebody updates a user and when somebody grants a role to a role or a user. So I could do that. Amazing class of security as well. Also, there's LDAP, Authnaut, there's key management from a cloud provider. So this basically ties your whole security picture together. With this, I'm going to be calling this session an end. Not the session, not the day. Stay on. My session an end. And I'm going to pass on the control to the team where we set up a couple of things. And I hope this resonated with you guys. And in case you guys have any questions at all, I'm right here, right? Feel free to ask that on the Q&A, on the chat, because if you don't ask questions, then I'm going to start asking questions. So feel free to ask questions and I'm going to take that up. Thank you so much.
Thank you, Sandhya, for this session. We do have a lot of questions for you. Okay, so the first question is, I'll be starting with the Q&A, and for all those who have posted in the chat, there is like so much discussion going on. So if you guys can just put it in the Q&A so that it's easier for us to see. So the first one is it necessary to go through SQL before learning NoSQL?
Short answer, no. Long answer, you don't have to necessarily go through SQL. It depends on what sort of data, what sort of use case your application has, and inherently what sort of data do you have? Is it structured sort of data? Do you have that component of rigidity and structure to your database where you want to store that data in tabular nature and join them? If you have a more modernized application where your data could be semi-structured, could be unstructured, you can always save that data in a NoSQL database. MongoDB, you can choose for the number of things that I mentioned, and trust me, I've just covered half, keeping the time in mind. So you could directly jump onto NoSQL. They're very easy. And the best part, they are, a lot of NoSQL databases are document databases, right? So you're already familiar with the JSON patterns. You're already familiar on how to query them with the JavaScript notation. So you can directly hit first, start from NoSQL.
That's great. So the quick answer is no, guys, you don't have to learn SQL. Another question from Neeraj is, I'm building a project using MongoDB. Initially, I will be having less traffic. So I want to know about serverless type and what will be it costing and how will the service be?
That's a very good question. That's a very, very good question you asked. So if you're considering serverless, you have to think as to, again, there's also a question on the chat. I will respond to that. Short answer, yes, there's a concept of foreign key like SQL. Back to your question, Neeraj, I'm sorry for that pause. For serverless, it's basically best suited for the applications that have a really sporadic sort of a data use. And typically, I'm talking about apps where the app could be super active, like few hours of the day, like let's say 1 or 2 hours during the day, or probably 1 hour or 6 hours during the week. Basically, the point with serverless is there's no upper cap or upper ceiling where your requests could go. So if you scale massively from 10 requests to 10 million requests, serverless will be able to accommodate that for you with no sort of a headroom given, no sort of a lag given. Since that is the pro, that falls under the pros, the cons would be the application usage could be such that it could be a bit expensive if you have a regular pattern sort of a usage of the application. Things like e-commerce, things like logistic application, retail, banking. These applications work day in and day out. So think about your workload, think about what kind of workloads do you have, and then we'll be happy to help you make that judgment as to what kind of architecture you could go with. I hope that helps.
Oh, yes, that does. Just a link question with this. Does increasing cluster impact the response time of the DB?
Depends, honestly. Okay, so this is the guest, Harshit. Okay. Increasing the cluster, impacting the response time, I don't believe so. When you could increase the cluster size is basically how much requirement of memory and the CPU compute do you have. So some applications could run on as low as an M10. We do have customers and prospects that want to use MongoDB clusters on M10. Then there are clusters and then there are customers that are running their clusters on as high as an M200. It is simply based on what kind of use you have. With every cluster tier, there's a change in the number of connections, there's change in the IOPS configuration, and IOPS is what control the the input output of the request per second. So basically, you can also provision IOPS going up a couple of tiers. So you will have a complete control as to how big of a bucket do you want for the request to get in and fetch the data from the database.
All right, that makes sense. So we will be starting with our next session now. And guys, please keep your questions coming. We do have a Q&A room as well after that session. So stay tuned. Sandhya will be there. She can answer your more questions there as well as with the other speakers too. So with that, I'll just pass it on. Yeah, please go ahead.
So sorry. In the meantime, I'll just try to respond to questions on chat that I can. I'll pick up the questions and then the rest we can just pick in the Q&A talk.
Yeah, so please make sure just keep your questions coming in the Q&A, maybe in the chat. Up to you guys. And with that, I'll pass it on to Sumanta and Shrey.
So just give us a minute. I will just share my screen and get started. 1 second, guys. Harshit, can you please check? I'm not able to share the screen somehow.
Just a second.
One second. Let me know, guys, if you can see my screen. Just
Yes.
bring up a couple of things. Okay. Okay. So 1 second. Okay, perfect. So hello everyone. How everyone is doing? I hope everything is well at everyone's end. So first of all, thanks a lot for joining us on a Saturday morning. I know it's like a weekend, and yeah. So today's topic is we will discuss about application-driven analytics with MongoDB aggregation framework. Basically, it involves integrating analytics capabilities directly into the application architecture so that you can do analytics on the database directly without adding a third-party source or connecting the third-party analytics software to your database, right? So this is what we will be discussing. Our presentation will be having uh, a deep dive into aggregation queries, and I will explain the things as we come along. So moving to the next slide. So talking about the introduction, here I am Sumanta Mukhopadhyay, working as a Associate Vice President of Tech at FinHub. I'm a MongoDB enthusiast and a MUG leader at Kolkata. You guys get me connected on the below things if you want. We have our another fellow speaker. His name is Shrey Batra. He's founder at Cosmos Cloud. He's a MongoDB champion and as well as a MongoDB MUG leader of Delhi NCR. So same like you can get connected to him on LinkedIn and Twitter. So coming back to our agenda. So we will be defining application-driven analytics. We will be talking about the use cases and the required capabilities. And we'll also discuss like how MongoDB will help it and how MongoDB will surpass these things. And we will be having a workshop, right? So going next, as explained earlier, we will be having challenge rooms for swags, hangout rooms for where you can meet other attendees, and the lightning sessions, which will be taken by the other fellow speakers. So what exactly application-driven analytics is? So by combining application logic and analytics functionality, application-driven analytics enables organization to extract meaningful insights from their data in a more efficient and streamlined manner. So in a conventional way, you will be able to understand your data much better in a very earlier stage, rather adding analytics at the end or somewhere near after the ETL or something. So we'll understand more once we deep dive into it. So this is a traditional separation of domains. What we mean by that is we have an application set where we run the business, and we have an analytics set where we manages the business. Obviously built by different teams, as it's explained, and it serves the different audiences. So applications is run by users, and analytics is run majorly required for the business or the stakeholders. So this is how the things has worked so far, and this is how it will be for the coming years. But if you see the current scenario, it is not enough. We need more, right? Because a user also wants to see, or a developer, not talking about user, let's say a developer also wants to understand the data more. So he should be aware of what the data is and how it is working. Same as for the analytics person. So if the same thing can be done from a single place, not keeping the things in a different place, right? So that's what we will understand, how the things are done in terms of MongoDB. So these are the demands of, we talk about digital economy, and yeah, we are nowadays we are having smarter applications, and we need faster insights. So nowadays on a click of button, you can see like what are your past orders, what are your past products in the cart, what was your past patterns, and whatever. You can click on a click of things, you can see this, right? And your app and our applications are pretty much fast for this. For these kind of things, if we can use application analytics where we can do the analysis on the top of data, so that is very good and that is like, it's very time-saving stuff. So moving back to the next slide, these are the industry examples where majorly we can solve our use cases in retail, in FSI, in manufacturing, in telco, in healthcare, and gaming. So these are the major examples where we can use in two ways, like either keeping the data or keeping the data as well as analysis on top of it. So I guess that's pretty much about this. I know this is a theoretical session, might be boring, but these are the basic things that everyone should understand before moving towards like a charts or aggregation framework. Like what are the things that we can solve using MongoDB, and if we start using it, right? So moving data into separate system obviously always takes time. That's a major thing that we do, like getting the data from the source and moving the data to the destination. That's what we generally do in the conventional data flow. And we call it as ETL or ELT sometimes. The full form is extract, transform, and load. And sometimes we do ELT as well, which is extract, load, and transform. So what we do is we take the data, we create a ETL flow, we move it to warehouses, data lakes, and then we perform analysis on top of it. But what if we bring everything to the left? That's what we call a shift left, right? So what will, just a second, one second. So that's what we call a shift left. What will happen is all the analysis and everything will be done in this data layer only. So what we see in your right will be moved to your left, right? So in that way, what we will be able to know our data, we will be able to understand our data in a much earlier stage, rather understanding in a later stage after ETL or ELT, right? So what are the implications of analytics shifting left? So let's see what are those. So we have tools and API to build sophisticated queries. Yes. So all the tools and all the APIs that MongoDB delivers, that is available. We can run aggregations. We can see charts. We can do dashboarding, everything right before the ETL. So we have everything on our fingertips. And a business will be able to understand it more, like how the data is growing, right? So in terms of business and in terms of application analytics, it is in both ways we are getting a good taste out of it, right? So moving back to next. So before, like I explained, like before the data was in separate systems, like here that there was a set of application data. These were the application data sets, and this was the this used to be the data warehouse or the data lakes or whatever we keep the data from the ETL, like the results of the ETL. And then what we used to do is we used to add like the user experience or a BI tool like Power BI or Tableau or QuickSense, or perform AI modeling on top of it, right? But what if we perform something like this? So what will happen is the application data remains at the place where it was and being consistent on the MongoDB, following the things which Sandhya has already explained, like the CP theorem. Then adding those user experience, BI tooling, and data sets just on top of your application data. So you can keep the analytics in both the places, either one if you need, but with respect to the requirement, you can keep it in both the places. So what will happen is you will be able to understand your data in your application stage only, as well as once you complete the ETL, then you can use the conventional centralized analytics system to understand the data a bit more, right? So the both things will help us to get more insights out of data and to get a better understanding of the data. So how MongoDB will help us in this, right? So the best thing about MongoDB here is like we get the ecosystem integration, distributed and secure, optimized storage formats, data tiering, and expensive person optimized query language. So the best thing about MongoDB Atlas and MongoDB ecosystem is it's about the availability. Like most of the API, it supports most of the programming languages, all the tech stacks. It is available and supported in major cloud providers, right? It is distributed and secure. It's the same thing which Sandhya has already explained, like how the nodes are distributed across clusters, across regions, and across service providers. and obviously like end-to-end security. Excuse me. So next is optimized storage formats. We can do a level of indexing. We can do row plus columnar indexing, and the storage suppose OLTP analytics access patterns. So these are the basic things that we get out of it. Now talking about the same thing, the use cases and solutions that we discussed last time. So these are the differences that we get, right? So in transactional database, we have DocumentDB, high-speed CRUD, high availability and scale out, row store secondary indexes, change streams, functions, and triggers. And obviously we have our Atlas search. And out of it, in the right, we have a wrapper of the integrations, like what we can do out of it, right? So MongoDB Atlas provides, it's a in-place solution for everything, where we can perform the analytics part as well as the visualization part. So we are getting two things at the same time in a single place. Neither we have to keep things in a separate places. Now everything is under one hood. So I think that's pretty much about my part. Shrey will be taking the things forward. He will be taking talking about aggregation framework and how it is useful, and a workshop session as well. So let me know, guys, if you have any queries or any doubts. I will be happy to answer. That's pretty much from my end. Thanks a lot.
Thanks, Sumanta. That was very good for you. And yeah, can you share this? Can you give me the screen access? I'll share my screen as well. Perfect. Let me know if my screen is visible to all of you.
Yes, it is.
Yeah, okay, perfect. So what is aggregation framework? Now, this is a very interesting topic, because most of the people, they tell me that, okay, they know MongoDB, are very limited to just the CRUD layer of MongoDB. Don't think of a database just, with CRUD layer and think that the database. No, that's not the specialization that you have to do. So what is after CRUD? It's something that is known as aggregations. Sometimes it's known as complex queries. In an SQL world, what you want to do is, let's say, joins, nested SQL queries, and so on, right? Now, the maximum complexity you can achieve in a SQL kind of world is joins, right? And nested queries. But if you want to do more of computation, if you want to do those kind of things that you would have to do it in code, but directly in database, there is where aggregation framework comes into the picture. Let MongoDB handle all the complexities, and you just tell what you want from MongoDB. Okay, so this is one of the most cool aspects. And if you know this, your application development would be very, very simple. Now, the topic for today's session is also building app-driven analytics or analytics-driven app, right? Now, that means in your live applications, you would need to calculate a lot of stuff, like leaderboard calculation, or top users of some place, or if you're using some kind of food delivery app, so best places to order from the food from, or hot services or hot tags, and so on, right? How do you do that? How do you calculate all of those complex queries without putting a lot of burden on your database as well, without bringing a lot of data to your code layer and then calculating in the code? So let's see how we can do all of that very easily using the aggregation framework. Now, what is an aggregation framework? Think about the read operations you do on MongoDB. It's a one single query, right? One single query with one single probably where clause. The maximum you can do is sort, count, limit. That's it. Now, if you want to do something more, that is where the aggregation framework comes into the picture, and it behaves like a pipeline. So that is why we are given a pipeline over here, and this pipeline is made up of stages. So stage 1, then stage 2, then stage 3, and so on. Now, every stage, it picks up all the records that it is coming, like all the inputs that are coming in this particular stage, and then it passes whatever it does in that stage, it passes the output to the next stage. So as a pipeline, the first stage is doing a database, a query on all the records that are there. And then after the first stage, let's say I want to match something, the second stage could be group all the records, but group only those records which are matched by the first stage. The third could be doing some other operation, calculating average, sum, whatever, but only on the operations returned by the group stage and not the other stages, right? So it behaves like a pipeline. This is the basic aggregation framework definition. Very similar, if you see the slide, we have all these records in our system, right? And what we want to do is, if you see the last line, it's an array of objects. So an array of objects means array of stages. The first stage is a match stage, behaves exactly like a query, that, okay, I want to do a where clause on status equals to A. So amongst all these records, only 3 of them matched A will pass on to the second stage. So only these 3 records would be sent to the group stage, in which the group stage says that, okay, I want to group by, so this is the grouping condition. I want to group by customer ID, given customer ID, and I want to calculate the total of amount, the total amount of each group, grouping by customer ID. Don't go over the syntax in detail right now. It's just a sample. I'll explain it very later. But if you get this concept, we are grouping it by customer ID. We have 2 documents of one customer and 1 document of one customer, and the output is exactly like this. So it's a pipeline with stages. Every stage modifies or does some processing and passes on to the output to the next stage. This is how aggregation framework works. Okay. I hope everyone is understanding these basic concepts. Now, too much theory, too much information over here. You don't need to learn all of these, but these are some sample stages and operators for you to use while building the aggregation queries or the aggregation pipelines. We saw match stage, group stage. There are things like geo queries you want to do facets, you want to do merge, you want to do sort. So many more. We'll have a look on this, on the exercises that we are going to do. And inside each of these stages, there are so many operators. I'm not even sure if this covers all the operators in Mongo, because there are hundreds of operators. But you want to do some mathematical operations, array operations, conditional operations, string, trigonometry. I guess you can even write JavaScript function internally. So that's how cool it is. So yeah, this is, you can go through in the documentation. Very similarly, if you compare the SQL joins to an aggregation, like join is only one type of stage in an aggregation. Okay, it's not the only stage. So if you're doing this kind of join from SQL, and how do you understand is that, okay, SQL queries have a nested structure that, okay, I want to join from this left join on this, and then I want to group by, right? I have nested queries as well, and so on. And then understanding the outer layer requires understanding the inner layers. So you would have to understand that, okay, all of this is required. And then we want to go from here to this particular select star, given T1 over here. And then we have customer that we are doing on the outer side and T1 on the inner side. It becomes complicated, right? Now, how does the same thing happen over here? That, okay, what we are doing is, forget about unwind right now. These are, I'll go through these later on, but just focus on the below 2 stages. So we have a match stage, we have a group stage. Similarly, we'll have a lookup stage. The joins are performed by a dollar lookup. That is a dollar lookup stage in Mongo, and you can perform joins. You can even perform recursive joins. So algorithms like BFS, DFS, and everything, you actually can do it, which you cannot do it in a SQL world. Okay, so we'll go over that later on. Some very simple, very easy to understand stages. So we have a match, we have a projection. Projection says that, okay, what columns do we want in return? What do we want as an output? Do we want all the 100 columns or only just few columns? Columns as in fields. And do you want to rename those fields or so on? Sort, limit, skip, count, etc. Right? So very simple, very easy to understand. Okay, I'll just quickly skip through these. These are all the arithmetic operators as well. I just told you about that. Yeah, let's head on to the workshop. Now, I guess most of you have already installed MongoDB, created a M0 cluster on MongoDB Atlas. If you have not created MongoDB Atlas account, I'm going to share you a read-only access link, which you can use to connect to MongoDB Atlas on my MongoDB Atlas. And you can use MongoDB Compass with me to run the queries along with me that we are doing. If you don't want to run it, you can just have a look. I'll be explaining all the queries and everything, as well as I'll be sharing the queries on the on a Google Doc. I'll be sharing the link right now. The link I shared right now is a read-only access link to my MongoDB Atlas account. You can connect over here, or you can use your own MongoDB Atlas M0 cluster if you have already loaded the sample data set. That would be very beneficial. Now, the other link which I'm going to share you is a Google Doc link. You guys can open this for reference of whatever queries I'm going to do. I'll be copy pasting the same over here. And we'll be, you can actually just reference those queries if you want to run locally. Perfect. So I'm just going to copy the two links again. This is the MongoDB URL to connect with your MongoDB Atlas, Compass or your shell or whatever you want to use. And this is the, Drive document link where I'm going to paste the questions and the queries. Okay. One more thing, there was a question just over here. How is it relevant to Mongoose? Mongoose is an ORM. It helps you wrap up some stuff, but understanding Atlas aggregations, you still have to write those aggregations in Mongoose. CRUD is not the world of creating production apps. CRUD is just a small thing. Okay. Now, okay. Now, how to go ahead? Okay, so how to load a sample data set? I'm not sure why the box is over here. You can just click on load sample data set, clicking the three dots on your cluster. Click on load sample data set if you have your own database, or you can connect to the connection string that I have sent you, and we are good to go. If you are not able to connect and if you're lagging behind, no worries. You'll have all the queries on the document and you can just follow me right now. Okay. Okay, so you can use MongoDB Compass, you can use MongoDB Shell. There is a shell inbuilt with MongoDB Compass. You can use any way to query your database. Okay, so what are we going to use? In the sample data set, we have a sample mflix database. Inside that database, we have the movies collection. So collection is similar to the table that you see in SQL world. Okay, so sample mflix database, movies collection. This is one document. It's a little long, so we have broken it down into 3 pieces. So we have the title, we have the year. Forget about this number int. It's just year : 1896. We just dumped it from BSON to JSON over here. That is why all of these extra characters are here. So there is an year, there is a runtime, that how long a movie is, when it was released, the poster URL, plot, full plot, all the directors, type, IMDb ratings, Rotten Tomato ratings, cast, countries, genres, and everything else. So we'll go through all of these. You can actually go ahead, you can connect to the database. You'll be, you can check out all the data over there. It's just for your reference. You don't have to check out over here anything. And, when we'll start. So it's not a negative number. It's more on the, it's actually a epoch timestamp. And if it's negative, that means it's before 1970. So the data is actually ranging from 1900s to 2020s. So don't worry about this data. It's just sample. What you have to do right now is you have to use the 2 links that were given. One is to connect to MongoDB Atlas along with me. And second is the database, the MongoDB Google Doc. We have not yet started. I'm not telling anything right now. If everyone is done, just you can put on the chat that you are done, and we'll go over this one by one. Okay. Awesome. So we have 5-7 people done. Even if you're not doing the hands-on, there is no worries. You'll have all the queries on the Google Doc. You can do it later. You can load the sample data set later. It's up to you if you want to do it on your account, if you want to connect to my account, whatever you want. Okay. Negative date, because it's the epoch timestamp. Epoch starts from 1st January 1970. If the date the movie was released before that, it will be a negative value. So the number of seconds from 1970 1st Jan, that's why it's negative. Okay, awesome. I don't go over the data. It might be correct. It's just sample data. Okay, it's just for some sample values. So don't worry about the data. Yeah, it's a really old movie. So we actually have movies from 1900s as well. Okay, so awesome. I guess most of you are already connected. If you have Compass, you can connect it with that. If you have Atlas, you can just go to Atlas. You can, just open your cluster. There's a browse collections button. You can just click that. You'll be open, you'll be in your collections mode. However you want to connect with the Mongo shell, it's up to you. Okay, so let's get started. And can you see my screen? I am on my Compass and I've connected to my sample DB as well. What I'll be doing is I'll be using the sample mflix database over here. I hope the font size and the screen is visible to everyone. They can actually read this. Any thumbs up, anything, like if the screen size is good, font size is good.
It looks good. Yeah.
Keep going. Awesome. So sample mflix, and we'll be using the movies collection over here. Okay. In this movies collection, if you see, we have so many documents. Every document is so big. There are genres, there is cast, there is so much else that is there. We have year of date, we have last updated on, type movie, Rotten Tomato ratings, IMDb, and so on, right? Okay. Now, how to build the aggregations. I'll be using the aggregations tab over here to do the aggregations. I'll move to the text one. You can move to the text one, or you can just click on the bottom of the screen. There's a Mongo shell. You can use the shell directly to query it. It's however you want. Okay. I'll be going to movies, aggregations, text. Now I'll be pasting my queries over here. You can do the same. Okay. Now this is an empty aggregation stage, empty pipeline, right? Now let's move on to the first question. Okay. So find the movies. Just give me a second. Yeah. Find the movies released in the year 2000. Now, it's a very simple query, very simple match stage, right? How we are going to do this? I'll just type this for now. This is match. So we have one stage, the match stage. Inside match, we have year as 2000. Simple. All the movies, if you see now, is of year 2000, year 2000, year 2000, and so on. Okay, so it's very simple, very easy to understand. I'll just paste this in question number 1. On the Google Doc as well, if you want to follow up, or you can just type in. Okay. Moving on to the next question, increasing the complexity. Let's say find the movies with a rating higher than 8. Okay. Now let's do this. How to do it is I'll copy my query over here, beautify it. So it's very similar. I'm doing a match stage. Inside my match stage, what I'm using is imdb.rating. Okay, so if you see, IMDb is a nested object over here. IMDb is a nested object with rating given over here. So if I want to query a nested object, I write it with a dot notation, IMDb.rating, and this is not an equals to value. If I want to use an operator, like I'm using a greater than operator right now, greater than 8. So I'm doing greater than 8. And if you see, all of my documents would have an IMDb rating more than 8 right now. Okay.
Yeah, I would pause you for a bit, and I think zooming might help a little. So yeah,
might help. Okay. So
to just zoom in, yeah, a little more, and this should be good. Yeah, I think.
Yeah,
I
okay.
think please let us know in the chat if you feel you should zoom more.
Perfect. Okay. So easy to understand, very simple, basic CRUD operations we are doing right now. Just understanding how aggregations work. What are a stage? $match is a stage. Inside the match stage, we are using just the query string, right? Okay. Coming to the next question is find the number of movies released in each year. Now, this is an interesting stage. That okay, what do we want to do over here? In each year, right? Now, in a SQL world, how would you do that? Right, okay, group by year, and then in each year you would do a count star or something like that, right? Very similarly, I'll do the same over here. This is a group condition, a group stage. Underscore ID of group is the grouping condition. That okay, I want to group by my year column or my year field. Okay, so I'll give that okay $year. That means Mongo knows that okay, this is a field in the existing database, in my existing collection. Group by year, and then calculate the count using $sum1. $sum1 as in for every record add 1. So do a plus equals to 1, right? So in 1918 we have one film. In 1985 we had 204, and similarly if you see we have 1984, we have some garbage value as well somewhere, and we have 1957 and so on, right? Now very easy to understand. Next one, find the average rating for all the movies released in each year. Okay, now all the movies released in each year, group by movies, and then average rating for all of them. Okay, very similar, we'll do it. I'll just copy the query as well, come back over here, paste it, do a beautify, and then okay, so we have a group stage, again grouping by year. Now rather than doing a +1 count or $sum1, we are doing average rating, saying that okay, in that group for every record, in use IMDb rating and calculate the average. So average of IMDb rating for every group, grouping by year. Okay, so this is how you can do. This is question number 4. Okay, I missed out question number 3 on the doc as well. I'll just quickly paste that. Question 3 is over here. Okay, so this is question 3, question 4. Okay, very easy to understand. I'm sure everyone is following with me right now. Now let's make it more complex. Find the top 5 movies with the highest average viewer ratings. Okay, so let's calculate the Rotten Tomatoes viewer ratings. Calculate the average ratings for every movie. Every movie might have multiple records in the system. So group by the movie, calculate the average viewer ratings, and then top 5 highest average viewer ratings. Okay, this is what we are going to do. Next question. So the query for this particular question, I paste it. Okay. Okay, no, this is the last one, right? Sorry, my bad. Okay, awesome. Now see what's happening. Now this is an interesting thing. We have multiple stages, right? So to understand this better, I'm going to switch to stages. And this is an awesome thing that Mongo that have done. Okay, so this is the native documents that are there in your collection. You can see the whole document. Now, if you scroll down, if I scroll down, you can see that, okay, the first stage, it does a group by that, okay, group by title of the movie, that, okay, group all the same movie documents together, calculate the average rating for every movie and say that, okay, calculate using tomatoes.viewer.rating. So there would be a Rotten Tomatoes nested object. Inside this object, we have a viewer, we have viewer rating. Okay, so group by the title, calculate average rating, and this stage gives you some answer like this, that okay, all of the movies have been calculated with the average rating. Second stage, we do a sort, that okay, now sort by this average rating that we have, this average rating for everyone, right? Sorted by descending order. -1 means descending order, +1 means ascending order. Okay, so given this, we have average rating 5, 5, 5, and so on. And now we want to have the top 5. So $limit 5. Okay, and now we just get the 5 documents with the highest 5 ratings. Go back to text. This is how the sample query looks like. Okay, so group, then sort, then limit. Okay, coming back on the questions, this was question number 5. I'll paste the query over here as well. I hope I'm the speed is fast enough, or should I go slow? Everyone's following up, right?
Yeah, I think Shrey could go even a little slow as well. All good.
Okay, awesome.
I mean, if you feel like, otherwise, I think we just asked everybody on the chat, and I think a few responded that they are able to follow up.
Okay. So I just had question number 5 pasted. Next, Let's increase it. Get the average runtime for movies in each genre. Again, this is a very interesting question. Okay. Now what happens is, let's go back and just see how our data is. If you see, every document or every record has an array of genres. Now this gets interesting, that okay, this has drama, this has animation, short, comedy, and this has, let's say, action and adventure. The question says each genre calculate the average runtime. So somehow we have to break this array first, then we have to group by genre and then calculate the average, right? So how will that be? I'll come back over here. I'll paste the query for question number 6. Just give me a second, just copying it. Awesome. So now if you see, there is a new stage for all of you, which is the unwind stage. Okay, let's see how it happens. Going back to stages again, these are the original documents. We have the genres as an array, right? What unwind does is it breaks down this array and create 3 documents, 1 document per record of this array. So if let's say I have only one, this is a cartoonist plot, right? Now in this cartoonist plot, there are 3 genres. So if you see over here, there is one cartoonist with genre animation. With the second one is the same movie with short genre. Third is the comedy genre, and then the next movie comes with its own genre. So what we are doing is we are breaking an array into individual records first, and then grouping by genre. That okay, now let's group the genre and calculate the average runtime. Okay. So this is how you can actually accomplish unwinds in the system. So this is a very, very useful stage by when we want to unwind an array into different records or different items and then do some processing on each item separately. Okay, so this is I assume there would be some questions. I'll pick it up at the end, but yeah, this is question number 6.
Okay, there's a comment that can you explain this again?
Okay, so what unwind stage does is it breaks the array into multiple records. So let's say this is a single record in the database with array having 3 values, right? Now, what it does is I cannot do a group by on an array, because if I do a direct group by on genres that give me the average rating for every genre, it will actually take this whole array as a single group. Like, okay, this is a single type of group, this is a single type of group, and so on, not the individual item, right? So what I have to do is I have to break this array into individual items first. That means I'll create multiple copies of this record, create as in within the query, not in the actual database. There's no update happening in the database. Within the database, after this stage, we have some output like this, right? That this particular cartoonist plot has 3 genres. It broke into 3 records: cartoonist with animation, cartoonist with short, and then cartoonist with comedy, right? Now it broke into 3, and now I can, so this output of this stage is the input of this stage, right? As a pipeline. So the stage 1 output is the input of the stage 2. Now I can do a group by that, okay, group by on the genres and calculate average runtime. Okay, so it's as simple as this. Okay, if there are more questions, I'll take it at the end. Okay, this is the question number 6. Question number 7. Get the list of unique movie directors. Okay, so again, now if I see in the original record, directors is again an array. Okay, directors over here is also an array. There would be probably 1 director over here. There is 1 director again. Not sure why there are 2 directors in this particular movie, right? Now, if I want to calculate the unique directors, what do you think is the first stage should be? Unwind. Perfect. Because I cannot do group by unique count on the array itself, right? I need to break that array into individual items, and then I can pick that items, put it as set properly, right? So from a DSA world, you would understand set as unique, right? So very similar. If I go back to question number 7 and copy the query of here, paste it, beautify. Okay. So now if you see, what I did was break the directors array into individual items, then group by. Forget about project for now. So what I'm doing group by is I am grouping by a null condition. This means that all the items in my database should be grouped together into a single group. There is no grouping condition. All the records to be grouped in a single group, and in that group I want to create a key directors, let's say sample directors, or let's say unique directors, right? Unique directors. This unique directors is nothing but a set that for every record in the whole group, add the director, the individual item of the director into a set, and this calculate this particular set. Okay. Now coming back to stages, if you see, by the way, I just changed this. I'll modify it over here. Yeah. Okay. So now if you see, this is the original records that we have. Coming down, what unwind did was it broke down into single director. So director became like this. Again, if you see over here, a director would be a single item and so on, right? Now, if I go back down, I did a group of all the records into a single group. ID is null, and unique directors, push it into a set. So even if there are multiple records of same director, it would be counted as one. Now we have, I guess, huge millions of records in the system. We actually have 23,000 documents. In this 23,000 documents, we have a total of 11,000 unique directors. Okay, so this is how the query works for this particular question. So this is question number 7. Okay, I'll speed it up a little bit. I'll take the questions at the end. We have 3 more to go. Find the unique joiners for country France. Now you would have understand how the things are working, right? So what we are going to do is we are going to do again an unwind and then group and then do an add to set. Very similar, but an extra thing came for country France. So what do we have to do is we just have to add another stage. The first stage probably that, okay, give me only the countries, only the those records which are from France. So only those movies which are from France, and then do the same thing again. Unwind on genres, because genres is an array. Group all of them together and send back the response. Okay, so very similar. I'm just going to paste it in. Question number 8. Awesome. Next question. Now, this is the most interesting question for today. Find the decade in which the most movies were released. Okay, now how do you think? I'm going to give a 1 minute chance to you guys. If you do a group by on years, it will actually take year as a single value, right? So 1961, 1975, 2022, so on. How would you find a decade? Not in Mongo, let's say in SQL. How would you do that? In anything, how would you find a decade? Range. So you can do a range query. Okay, so you can do year is less than, greater than. What I'm saying is I want to build an e-commerce application and I want to build the filters over there. So I want to get all the records which are from 1960 to 1969. And then another second filter would be 1970 to 1979. If you want these groups to be created, okay, there is Laksh over here. He took the correct stage over here. That's $bucket. And if I come back, this is a very good thing. I'll show you. And these are complex stages. Okay, so if you actually get these stages, it's one of the most complex stages. And if you get this, understand this, it will be the one of the most perfect thing. Okay, so this is a stage bucket. It is like a group stage, but like an advanced group stage that say that, okay, group by year, the boundaries of the buckets are defined as these. There might be more movies in 2000 ranges and so on. Or let's say some document might not have a movie or some, missing information. The default value will be other. Like if the year is not there or an invalid year, then put it in the other bucket. Okay. And then whatever groups you are making, for every group, calculate the count. So let's say this is the count or number of movies, whatever you want to name it. Count is nothing, $sum1. We saw it previously. So this is the advanced group bucket. Group by year with these boundaries. Put all the other non-matching records in the other bucket. Calculate the count of each bucket. Now I am removing the other bucket, saying that, okay, I don't want. So when you group by, all the groups IDs are the underscore ID. So I'll say that, okay, remove the group which is not equals to other. I am not interested in that particular thing, and sort it by number of movies -1, saying that, okay, in 1980s decade, 2000 movies were created. In 1970 decade, 1252 movies were created, and so on. So now this is what is more amazing, that, okay, if you want to build an e-commerce app, you want the filters. On that filters, it shows the number of records would be there if you select that filter. It is very similar to this particular real life use case. Okay, so this is a very interesting stage that we have. I'll copy this, quickly move on. Question 9. You guys can check it out. And then the last question for the demo is find the name, title of the movie having the most comments. Okay, so find the name of the title, name or the title of the movie having the most comments. Okay, so very simple, very easy. Again, no advanced stages in this. I'll just pick it up, paste it over here. And if you see, what I'm doing is I'm just doing sort number of mflix comments. So if you see, my original data has a column says, or a field says number of mflix comments. So it's 0 over here and it's 0 even over here. So this has 1 comment on this movie and so on, right? So what I'm doing is I'm sorting it in a descending order. And why I'm doing a skip? What's the question says? Okay, the question says the having the most comments. Actually, the question was supposed to say the second most highest comments. Okay, so if I want the second most highest comments, what I can do is I can skip the first value and then return the next one value. Okay, so the second most highest, if I want, I can skip the first and then return just one. I can just say I just want the title and this, not the other fields. Okay, so this is how pagination works in the system. Skip the first 10 records, give me the next 10 records. Next page, skip the first 20 records, give me the next 10 records, and so on. So this is how you build aggregation pipelines. The output of one stage goes as input to the next stage, and so on. I'm sure there are queries and all. Harshit, how do you want to do this? Do you want the queries first? Or should we move to the small 5-minute demo to charts? We can do 5 minutes question first, right?
Yeah. Keep going. Yeah.
Okay, so I'll check the questions first, as well as if you guys have any sample use cases you want me to build a query for, and if I'm able to build it right now because it's doable or feasible, I'll do it right now. So go over to the main documents, check out the document and think that, okay, what if I want all the movies released in the last 1 day, or having X number of amounts, or doing this, that, whatever. Think about some use cases I might be able to solve over here, and you can post your questions as well. I'm happy to answer. Okay, so 26 multi-document. Okay, I'll take the multi-document transaction later after the session. Okay.
Yeah, just to remind everyone, we will be breaking out into breakout rooms after this.
Yes.
And there would be a hangout room just for you to all to like Q&A, meet Shrey, meet Sandhya, ask any questions you might have. So you can just, bring up your questions that might be relevant, that might not be relevant for right now, but could be relevant for later. Or if you have, further questions as well in the breakout room, and you can chat over there. And we can also have fun in the breakout room, like you were discussing food for today. So we can all hang out there and meet everyone as well. Yeah.
Correct. So there is one question: how does $bucket use index? So $bucket does not use index. It's a grouping condition. How it retrieves the document from Mongo is how it uses the index. let's say you have a match condition before bucket that, okay, give me only the documents from year 1980 to 1990. And if you have an index on 1980 to 1990, the query, the first stage of the query actually goes to the database, gets the records. If it's using a match stage, let's say, or if using any index, it will use the index to use the, get the records. And those records that are already in memory, the $bucket uses a grouping condition. So under the hood, it's just a complicated group condition. Okay. How can we fetch movies released decade-wise without setting manual boundaries? Perfect. Now, there is another way of doing a bucket auto. The issue with bucket auto is it does not understand the boundaries. Okay. Now you logically know that as human, that there is decades in the system. If for the Mongo, it is just an integer. It can be an age, it can be a kilometer range, it can be a speed, it can be whatever, right? It can just be marks. So it doesn't know that, okay, it's actually date values and it need to bucket on decades and all. So boundaries you'll have to set yourself. What you can do separately is you can actually use bucket auto, which will not solve this particular thing. But if you use $bucket auto, I'm sure you can see my screen. And what it does is it automatically, buckets all the records in the defined number of buckets. That, okay, if I want to group by price and create 4 buckets, it will automatically create 4 buckets saying a min to max range is like 75 to 159, we have 2, 159 to 199, we have 2, and so on. Now, these ranges or this min max is not defined. This is not how bucket auto works. Okay, so bucket auto automatically divides it into 4 buckets. And how to divide it? Equal division, or the distribution of the data. There are more complications into this, granularity and everything. You can study it in the MongoDB documentation. Happy to help out after the session as well. Okay. Okay, so last one thing I'll be solving, it's Harshit's question. Suppose you want to rank the movies on the basis of, basis of likes and comments combined, giving some priority to likes, say, let's say 1, and some other priority to comments. Oh, very perfect question. Nice. Okay. So this is something that was missing in the demo as well. Cool. So we have likes and comments, right? Where is the likes key? I'm not able to see it. We have the comments key and languages, release, writers, awards. I'm sure we have the likes key, but I'll just give you an example of it, how to do it. Okay. So cool. Okay. Now let's say you want some kind of, movies in the system, let's say by some doing match, group, whatever. And then let's assume, I'm just marking it as comments over here, that we have something very similar to like this, name of the movie. And we have number of likes as, let's say 5, and number of comments, let's say 10, just for example. Okay. Now, if you see, how do you calculate this rank? Okay. So first way is to use a full text search. Very good. But if for this very simple use case, you can just do a $project. Now, $project is like a projection. You can say that, okay, I want X field, I don't want X field, right? Including, you can create pseudo keys. You can create more keys as well. So I'll say my, rating or something is equivalent to add. Let's say I want this thing, right? Number of likes into 1 plus number of comments into 2. So weight, this is weight 2, this is weight 1. I want the whole sum of this. So this is my rating, right? Very easily, I'm just able to talk to you about. Okay. So now rating is add, $add. We want 2 things, 1, 2. Okay. In the first thing, I want to calculate the multiplication of 2 things. So I'll do $multiply, or I just product or multiply, something like that. So, and then multiply what? We want 2 things again. One is dollar number likes. Assume this is a key already in the database in the collection, and then multiply it by 1. And second thing I want is multiply, and this is number of comments into 2. So we are doing number of multiply this by 2, this by 1, adding both of them together, calculate the rating. And then after this rating, let's say I want the top 5. So very simple, $sort by rating as descending order, and then return back the top 5. So $limit as 5. Got it? So calculate the rating as a query kind of thing, and then sort it, and then limit the top 5. Awesome. You guys got this?
I have one last question before you move ahead. Yeah.
What are you saying?
I have one last request before you move ahead, like before you go to the breakout rooms, which is, or you show the charts. Can you help me pick a movie, pick a latest action genre movie with the highest average rating for my weekend, actually?
Okay, so what did you say? Latest?
So latest action genre movie with the
Action.
average rating.
Okay. Latest action movie, that's it.
And I mean, if you can sort it on the rating, the highest average rating to get that. Sorry, I'm making it complex.
So let's pick up the action genre movies first. Okay. So let me remove this. Genre is drama. This is probably action. Yeah. So we have action. Okay. So I'll do genres. Why it's not coming?
Match.
Oh, sorry, my bad, man. Okay. So I'm getting all the movies that has at least action. Okay. Now I want latest action genre movies with let's say a high rating, right? So I want, let's say, a rating at least 10. So I'll just say imdb.rating as at least, not at least 10, at least 8, right? So dollar greater than 8. At least means at least greater than equals to. So greater than equals to 8. Okay, these are all the movies. And let's say you want the latest movies. I'm not sure what date range this has, but we have something known as released key over here. Okay, so what I'm going to do is sort by released as -1. So descending order. So this was the latest movie, and we have so many movies. So this is 2015. We have 2015. We don't have movies more than 2015. Okay, and then let's say I want to give 10 suggestions, or let's say 2 suggestions. Limit 2. And I just want the name of the database, name of the movie. So $project, title as 1. I'll just beautify it. Okay. And there you go. You can see Kangfari, or you can see Miru. I'm not sure which language these are in, but you can actually just see which language these are in. I'm sure you know English. So you can just go ahead and you can just take that.
I'll respect your efforts, and even if it's not in English, I'll just use the subtitles. Thanks, Shreya.
Awesome. Okay, so I'm sure you guys got what aggregation pipelines are. And the last thing on analytics and building apps using analytics, we have something known as MongoDB Charts. Okay, most of you might know or might not know. What you can do is you can build interactive charts and reporting and dashboards directly from MongoDB on your database, on your live database, without copying that data to any other place. Okay, so you don't need Kibana, Elasticsearch, Power BI, ABCD kind of stuff. Okay, so what I'll do is I'll go to charts over here. It's a free service. I'll go over here. And what you can do is the first time you go, there will be an activate charts button. You can just activate the charts. It will take 30 seconds. You can just see my screen for now. What I'll do is I'll add a new dashboard. I'm not going to use the previous dashboards. Let's say sample, what do you want to say? vMUG dashboard, right? Is my screen big enough? Okay, now it's cool, right? Okay, now I'll start creating my first chart. Now this is the most powerful way. It's a no code way. So the first thing you need to do is connect to the same Atlas cluster that you want. And I have one Atlas cluster in my account. I'll use this. It takes a few seconds to load all the databases. Okay, in this databases, we have sample and flicks. I'll use that. And in this, I want to connect to the movies collection. So you can just use select. It's already selected over here as movies. And now what chart do you want to build on? So let's say I just want the number of movies in each decade, right? Okay. What do you want to use? Group column or bar chart or column chart? So I'll use a column chart. Now in the column chart, if you know, it's something similar like this. This is the categories. X-axis is the categories and Y-axis is the processing or the calculation, right? Which is known as aggregation again. Okay. So now in the X-axis, the categories, let's say I want to group by take the year as the category, the total number of movies per year, right? So I'll put it over here. I'll just drag it, put it on X-axis, just switch off binning for now. And then on the Y-axis, I want to calculate the number of records in every year. I can just use the underscore ID, right? The primary key. So count star or count ID or something like that. So it's just drag and drop. You can use count, you can use whatever you want, distinct. And so like this is distinct, but if it's price, you can do average price and everything like that. And there you go. It's an interactive chart. You can see that, okay, in 2014, we had 147 movies. In 2013, we had 1220 movies. Now, if I just want to do by decades, I can just start, just plug in binning. Binning means created into buckets or bins. Size is 10. It will automatically do it for me. And if you see in 2000, there were around 7,000 movies that were released in the year from the year 2000 to 2010. Again, this is the complete set. Okay. So this is how easily you can create all your charts and everything. And you can just click on save and close. So as soon as you click on save and close, this chart is live over here. You can refresh this settings. You can say that, okay, I want to refresh this all in every 1 minute. Let's say you have an active system, transactions happening, 10-minute grocery app or whatever, and you want to see that, okay, what is the transaction count every minute? You can have a refresh setting over there. Again, it will add load to your system as well, but it's super easy to calculate this. Something very similar, I can just use movies again. Let's say I want the total number of movies, no, not movies, let's say total number of movies of France, only of France, right? So I just want a number. So I can just go down, click on number chart, like this chart, and I can just say I want the count of all the movies. So I'm just pasting the primary key or the underscore ID, count of all the movies. Now this is going to give me all the movies, right? But I just want to add a filter clause or a custom aggregation pipeline over here. I can do everything if you want over here, okay? So I can just say, let's not use query, let's use aggregation again. I'll use a $match. Again, over here, so I'll just format it for you. Okay, now the match, I'm just going to say countries is the key and France is the value, format, apply. So if you see, it will give me all the movies of countries France, and there are 3,000 movies in countries France. As soon as a new movie comes in, automatically when my chart refreshes, it will say 3,094. So it's as simple as that. You can save and close. This is my second chart. You can increase the size, you can decrease the size, you can do whatever you want. And the last thing that I want to show you is share. As soon as you click on this share, let's say I want to make it public, I can view the dashboard, copy this. Everyone with the link will not be able to view the data in that. You'll not be able to view the data. I'll copy this. I can open it in a browser and share it wherever I want. I can embed it in my application and so on. Again, it's not able to retrieve the data because allow unauthenticated access and save. Okay. Now, if you refresh this, it's already there. So if I just paste this in the chat, I'm sure everyone can click on this, can see my dashboard that I have made. And this is how soon you can actually create your dashboards. You can, for your production, for your samples, or whatever you want. Okay. So I hope you learned something today. There's something you can, take back. And if you have any questions, put it on Q&A, put it on chat. We have some breakout rooms. Harshit might be talking to you right now. We have more sessions coming up. So awesome. And thanks for my session. Thanks for hearing me out. If you have any other questions, let me know. Do reach out to me on LinkedIn as well. Happy to help you out. Yeah, so I don't do YouTube videos as well. So awesome. You can just follow me on LinkedIn. There are my blogs and everything. You can just check it out as well. Okay. So thank you. And over to you, Harshit. Thank you.
All right.
I'll show you my LinkedIn account. You can just search me, Shrey Batra, and probably the first name over there. So awesome.
Yeah, he's the famous one. You will find him. He's the first one. He's the only Shrey Batra you'll see on the top. So it's easy. Thank you, Shrey. Thank you, Sumanta. This was a great session.